What I want to talk to you today about a bit is previsualization. So we're all really very familiar, and many of the pictures today and many of the presentations we've seen today have shown previsualizations, these renderings, fly-throughs, pictures, drawings, and the massing studies and other architectural endeavors that use these tools, these 3D tools, to create some idea of what it is we're going to see when we finally put the thing in the space. And these tools, these CAD tools, have really changed the way everybody works. And the opportunities they create for a work practice that is cyclical and iterative and creates dialogue and discussion from the beginning of a project through all the different stages of the project, by creating these artifacts, by creating these models and critiquing them and looking at them, is just standard practice now, of course, through all design disciplines. The things we're designing here, as you've seen in the last couple of presentations, and many of the presentations this morning, are incredibly complex. So though we have this kind of iterative and cyclic way of thinking about the physicality that we inherit from other design disciplines and from architecture, et cetera, when we start talking about these systems that, as Dana was showing so clearly, are so embedded and imbued with all of the different actuators and sensors. The diagram on the left is showing the block diagram of a current piece that's being worked on, a current test bed. There are tiny computers and actuators and sensing devices and wires and cables and different power splitters and all this kind of stuff going through all of these different, all of these test bed installations. They really make the nervous system that lives within the skeleton that we've used these tools to create. And they enable all of the extraordinary breadth of behavior. As we've seen already, and as we're seeing right here, people come to these and they respond and they react. The question is, as Dana also was asking earlier, how do we decide what they do and who should decide what they do? And there is so much room, such a broad canvas for exploring this question of how do these behaviors get generated, how should they get generated, what do we want to see, what are the goals, what are the action conditions? And what you see on the left is some designers designing some of those behaviors. The issue is that often this design is compressed. It's necessarily compressed because in order to do that, you need the thing. So the thing gets built, the thing gets created, and then all the ideas and all the conversations and all the potentials of the device and of the space that we've been imagining need to be articulated and played with and iterated and designed in a very compressed space. So the question is, how do we establish the same kind of rigor and tools and methods that we use in the physical space to actually design these kinds of systems in a behavioral space? And because I have always sort of worked with this sort of methodology, I'm super happy to be coming to LASG and sort of trying to think that way. So here are a couple of very quick projects that I've worked on in the past. This is a piece called Solar Collector that I was done in collaboration with my partners Rob Gorbet and Susan Gorbet, a lot of Gorbets in this one. And what you're seeing here is a sculpture on the left, but on the right, it's already switched out, but on the right, what you saw was a visualization that we created long before we created the piece. And the visualization was able to help us establish how the behaviors would work in the piece, and in fact was instrumental to determining the form of the piece. So behavior preceded form in this case. Another piece that I worked on with collaborators Bani Banerjee and Maggie Orth was a piece in an airport in San Jose. Here's a piece of a multitude of different shape-shifting nodes that hang from the ceiling. But what you see on the bottom is the very early software that was created long before the physical pieces were even finalized in their form, that was used to control and choreograph this piece. And so being able to sort of pre-visualize behavior as well as being able to pre-visualize form leads to this intersection, leads to this idea that we can actually create just one conversation that is iterative. So this is, in December, we held a behavior workshop at the LASG in the studios here in Toronto where we were addressing some of these questions and asking about them. We had a very broad-ranging conversation about how does software work on these pieces. And what has come from that, or what is emerging from that now, it's beginning to emerge from that, is a system where as the models are being created and the massing and the design is being done, what we can start to do is extract from that all the different components that are part of that sculpture plus their three-dimensionality into a very simple table that can be then imported into a system that is not simply a visualization of the sculpture as it will appear, but it is also a visualization of the activity of each and every one of the little components within them. And it's architected in such a way that the pieces with the elements within the piece are running exactly the same code that they'll run in the physical world. And all of the messaging that is happening across the different wires and cables throughout the piece is actually happening internally in the virtual world as well. And it happens simultaneously. So what this enables us to do is to decouple in time the activity of designing the physical piece and the activity of designing the behaviors. We can start to talk about behaviors at the same time as we talk about the form, and they can influence one another. So you were just looking quickly at a bit of the visualization there. I can't really point to this, but at the top, given what we heard in Dana's presentation, what I'm really excited about and what we're all really excited about is as we implement all these little parts of this very complex system in software, the big open space that becomes a canvas now is this bottom section, behavior algorithms. And what the behavior algorithms let us do, now that we have a simulation of the physical test bed, the behavior algorithms let us start to play. What will those behavior algorithms be? Will they be choreographed movement as designed? Will they be action potentials? Will they be stimulus response algorithms? Will they be physics simulations? Will they be machine learning algorithms that are implemented within this test bed, within this system? Will it be all of the above in concert and in conjunction? Will we be able to do some of this and then branch off with other pieces? Will there be emergent behavior? There has been a lot of amazing conversation, even today, even just in this last presentation, about beautiful emergent behavior by lots of distributed agents. And those agents and that learning and that surprise. Somebody said earlier the idea of catalyst, the idea that the piece could catalyze new behaviors that were not designed into it. All of this is able to be experimented and explored within this software testbed at a virtual level. And we can start to play with external data both coming into the system and going out to the system to other research. So it will open up these pieces to an easier and a more fluid and a sort of more graceful integration into other research, whether it be visualization with more complex systems that want to do like game engine type graphics or VR, or potentially in the STEM world, or potentially even coming into more physical objects. So that's the concept of what we're starting to build, giving ourselves an iterative ability to work in concert at the same time on the behaviors and on the physical design together to really just have one conversation. I think the bigger picture, I mean, this is all about LASG, and it's about sort of starting to get into a world of living architecture. But the bigger picture, as it relates to things that we were seeing this morning, is when we begin to imagine a world where every designed object, every manufactured object, is designed and manufactured with an idea of how it will behave, not just how it will behave in physics, but how it will behave in interaction, how it will react, how it can be dynamic in the world. And you know, when I think of this, I think of a far future world where objects have their own behaviors and can move and morph and make decisions on their own. But I have to say, after this morning's talks, that far future world is actually right here, right now. So a lot of this question of what does it mean to design objects that are living in this context, to me comes down to tools and methods. How do we engage in a design that balances and celebrates both the behavior and the physics and the physicality at the same time? So thank you for that. If we have a question, I'll take it. If not,
thanks for the great presentation, Matt. I just have a question, actually, which is a little bit to both of you, so you and Dana, but maybe you can answer first at least. Are you considering connecting the two aspects of your work in terms of incorporating the potentiality of the expected responses of people to the behaviors that you are simulating in the system?
Absolutely, and I have to say this is still very early days. This was sort of born out of some ideas that came out in December, so we're really at the point of just getting to the alpha version of what we can do here. But beyond this, the actuators, we are also designing and simulating the sensor aspects of this. So everything that is happening in this will have a way of being modeled and also being interacted with from the desktop by designers. And there will be space to take the algorithms that we're talking about here to drop them in and play with them to get a sense for how to tweak and balance and train them, really, because a lot of it is about teaching and training before the piece is ever built, and then let it continue to surprise us. So absolutely, I mean, it's all about collaboration and better tools for collaborating. So, did you want to say anything, speak to that as well? It was a question to both of us, so.
Yeah, thanks for the great presentation. I'm super excited about this basically new capability of the system. And I think, coming back to your question, this interface is exactly what's going to enable us to create, to basically link the two streams of research together. And so what we can do is, we can have better initial behaviors that the designers design before the system is even physical reality. We can run learning algorithms inside the simulation. Of course, the challenge there is how do we generate user responses in the simulation,
right?
So then we will have some limited user models where we can get some initial learning. Then we can go to a physical system, continue learning, and then we can bring the model back to the designer, and the designer can play with it and iterate on it, and then bring it back to the world.
Yeah.
The only thing that I wish you had done is you had your two loops. One was the behaviors, and the other was the physical system. And I wish that there was a possibility to also integrate the two loops and think about kind of what you talked about with your earlier work.
Yeah, they should come together as one conversation. Absolutely, absolutely. I agreed. Yeah.
Thank you.
Thanks. Oh, I also want to be very clear that this is all built on years and years of software by Matthew Chan and by Adam Francie and by all of the other collaborators who have been working on this. So we're not throwing that out and doing something new. We're actually integrating and incorporating it as much as we can. So, thanks.